So, hello dear students, uh, can you hear me? Just write your name and roll number in the comment box. So, attendance will be marked in the first 10 minutes. Let the other people also join, then we will start our lecture. So, I will consider only those students are present who will mark their attendance till 9:25 a.m. So after that I will also consider the attendance one more time during the lecture. So what we are talking about is we are talking about the relation of microstates and the development of the various physical parameter, thermodynamic parameters, and how we can derive these parameters from the microstates. So we have derived the relation of entropy, and from that we have derived the relation of internal energy, and from that energy expression we have derived various thermodynamic parameters, such as we have developed the relation of pressure with entropy, we have developed the relation of temperature, we have developed the specific heat relation. So this is how you can develop various thermodynamic parameter relation from the microstates. So what type of system which you are choosing. So in today's lecture we will discuss a very important article, that is the Gibbs Paradox, and how Gibbs has corrected the relation of the entropy expression which we have derived, and he has resolved this entropy expression, and which is generally named as the resolution of Gibbs paradox. So in the entropy expression, so we have developed the relation of entropy, that is k log of gamma. So where the value of s which we have derived, that is nk log of v over h cube 4 pi me over 3n the power 3 by 2 plus 3 by 2 n into k. So this expression of entropy, so generally it is considered as not an extensive properties of the system, because we know that the molecular entropy of a system, which depends upon the molecular interactions which are present in that particular system, and generally we consider as entropy as the intensive properties of the system. So what does it mean? So if it is considered as not an extensive property, so which depends upon the physical parameters of the system. Now if we increase the system size, now if we increase the size of the system by a particular term, so if we increase the system size by alpha, so keeping the intensive parameter changed, then we know that the value of n, which is the extensive property, its value, it goes into alpha times n. The volume, it also changes to alpha times v, and energy of the system, it also changes alpha times into new energy, that is E. So these are the new parameters of the system. Now according to the given equation 1, so the value of the new entropy, it should be also increased by a parameter of alpha times n. So it should happen. But in actual, what they have observed, that the value of the new entropy, it is not directly equal to alpha times as the value of the previous entropy which we have derived. So there is some sort of lagging in the entropy value. So Gibbs has derived this expression, and he said that so this may be due to presence of the log v term which is present in the above equation, that is equation 1. So this is something like this may be log v term, it is causing it is not giving the exact equation of entropy for every system. So the entropy of the system, it is different from sum of entropies of the different parts. So this is known as the Gibbs paradox, because the value of entropy it is not coming same when we sum up all the entropies of the different parts. So what he has done, so he has tried to solve the entropy of the system for different gases. So we can write this entropy equation, so that is our equation nk log v over h cube 4 pi m over 3n. So if we put the value of E, that is our classical ideal gas, so 3 by 2 nkt, 3 by 2 plus 3 by 2 into nk. So this equation becomes v over h cube 2 pi mkt the power 3 by 2 plus 3 by 2 nk. So we further move these terms within the bracket. So this equation becomes nk log of v 2 pi mkt over h square 3 by 2. So our main motive is to separate these log v term from this equation plus 3 by 2 into nk. So this equation becomes nk log of v plus 3 by 2 nk log of 2 pi mkt over h square plus 1. So this is the same equation of entropy which we have derived in equation number 1, but in the form where we have separated this log v term from the bracketed term. So this is our new equation 1, so that is the same equation 1. Now let us use this entropy value to solve the value of change in entropy when we mix two systems. Now first case is mixing of two ideal gases, two different ideal gases, 1 and 2. So the condition is both at initial temperature T. So both have same temperature. So let us say this is our first system, so whose number is N1 V1 at a temperature T, and the second system whose gas is different having number N2 V2 and T. Now when we mix these systems, so the value of entropy before mixing will be, so when we have not mixed these two systems yet, so in that case the value of entropy of system 1 is N1K log of V1 plus 3 by 2 N1K log of 2 pi mkt over h square plus 1. So similarly, the entropy before mixing for system 2, that is N2K log of V2 plus 3 by 2 N2K log of 2 pi. So here the mass will be also different. So M1, so here we will write M2 KT over h square plus 1. So the total entropy before mixing, so that will be equal to S, that is S1 plus S2. Now when we mix these two systems, so the value of entropy, so let us mark these equation, so as equation 2, so entropy after mixing, so when we mix these two systems, so some N1 particle it starts to move towards the system 2, and some of the particles of the gas 2 it will start to travel to the system 1. So all the gases will mix up, then the entropy of system 1 after mixing, that is equal to N1K log of V. Now V is V1 plus V2. Now when we have mixed the system, then the value of entropy it will be for the whole volume. So we will write here N1K log of V plus 3 by 2 N1K log of 2 pi M1 KT over h square plus 1. So similarly, entropy of system 2 after mixing, that is N2K log of V plus 3 by 2 N2K log of 2 pi M2K T over h square plus 1. So this will be the value of S1 dash and S2 dash when we mix these two gases. So the value of entropy, that is after mixing, will be equal to S1 dash plus S2 dash. So that is for the whole system S2 dash. So increase in entropy is called the entropy of mixing. So entropy of mixing will be equal to, what is the change in value of entropy, that is after mixing and before mixing. So that is increase in entropy So that will be equal to delta S. So it is equal to entropy after mixing minus value of entropy before mixing. So when we put the value of this S1 dash plus S2 dash minus S1 plus S2, so from that we can calculate the value of entropy of mixing. So let us put these values. So subtract equation 3 from equation 2. So let us first write the value of S1 plus S2 dash. So that will be equal to N1K log of V plus 3 by 2 N1K log of 2 pi M1KT over X square plus 3 by 2 N1K plus N2K, that is for the system S2 dash, plus 3 by 2 N2K log of 2 pi M2KT over H square plus 3 by 2 N2K. So similarly you can find the value of S, that is S1 plus S2, that will be equal to N1K log of V1 plus 3 by 2 N1K log of 2 pi M1KT over H square plus 3 by 2 N1K plus N2K log of V2 plus 3 by 2 N2K log of 2 pi M2KT over H square plus 3 by 2 N2K. Now when we subtract these two equations, so the value of delta S, it comes out to be, so you can check that these values, so they get cancelled out. So this get cancelled with this value, this get cancelled with this value. So what we are left with is N1K log of V plus N2K log of V minus N1K log of V1 minus N2K log of V2. So this we can write, so taking K as constant, common, N1 log of V plus N2 log of V minus N1 log of V1 minus N2 log of V2. So that can be written as K over N1 log of V over V1 plus N2 log over V over V2. So this is the new value, so that is our equation number 4. So putting the value of V, so V we know that is equal to V1 plus V2. So the value of delta X, that is the change in entropy, so that will be equal to K N1 log of V1 plus V2 over V1 plus N2 log of V1 plus V2 over V2. So this is, so the value of this delta S, it comes out to be a positive quantity. As what does it shows? So it shows that the above expression or the above mechanism which we have done, so that is a irreversible process. So what does it mean? When we mix these two gases, So if we try to separate again, we cannot make the process in their initial state. So we cannot separate these two gases once we mix them. So what does it mean? So the above mechanism which we have done, so that is a irreversible process. So until now the value of this entropy expression, so it is justified. Now he done the second case. So what he done, he take the two particle density, he mixed two same gases. So mix two same gases, so having same particle density, so everything is same. So from when we mix these two gases, then the expression of particle density, that is N1 over V1, so it is equal to N2 over V2, and when we mix these two gases, so the total number N1 plus N2, it will be same as their initial density V1 plus V2. So this expression we can write N1 plus N2 over V. So everything is same, so N is same, V is same, T is same, so all the particles having same particle density. So the above expression 5, it becomes, so delta S, so we can also write it something like N1 log of N1 plus N2 over N1 plus N2 log of N1 plus N2 over N2. So here now we have to find how to find paradox. So where is the wrong portion in the value of entropy? So let's try to find the paradox. Now if we consider, if we are mixing same gases, so having same particle density, then the value of M1 and the M2, that will be equal to M2. So let us suppose we consider it as M. So in this case the value of entropy after mixing, so that will be equal to S1 dash plus S2 dash. I will not do the same calculation, so I will just write the results by combining the value of S1 dash plus S2 dash. So you can try your own, and if you have any doubt you can ask. So the value of S dash, it is coming out to be N1 plus N2 K log of V plus 3 by 2 K log of 2 pi mkt over h square into N1 plus N2 plus 3 by 2 N1 plus N2K. So what we have done is we have considered the same volume of the whole system, V is equal to V1 plus V2, and here we have considered the value of M1 and M2, that is equal to M. So M is same as M1 and M2 because the two gases, they are same in the two system. So S dash comes out to be, we can write this N1 plus N2 as capital N. So this equation becomes Nk log of V plus 3 by 2 K log of 2 pi mkt over h square plus 1. So when we take 3 by 2 nk as common, so this is into n1 plus n2, that comes out to be n. So this is n. So this equation becomes nk log of v plus 3 by 2 nk log of 2 pi mkt over h square plus 1. So this is the value of entropy after mixing. Now let us try to write the value of entropy before mixing. So entropy before mixing, so इस केस दे विच जिहड़ी वैल्यू दी होएगी, so that will be equal to s, which is n1k log of v1 plus n2k log of v2 plus 3 by 2 n1k plus 3 by 2 n2k plus 3 by 2 n2k log of 2 pi mkt over h square plus 3 by 2 n1k log of 2 pi mkt over h square. So let us say this is equation number 7, this is our equation number 8. Now we have to find the value of change in entropy or entropy of mixing, so that is equal to s dash minus s. So when we solve it, it is coming out to be k n1 log of v1 plus v2 over v1 plus n2 log of v1 plus v2 over v2. Now if you look at this equation number 9, so compare equation 9 and equation this 6 or 5, they are more or less the same equation. So if you compare this equation 5, so compare equation 9 and equation 5, so the delta S is coming out to be same. ਹੁਣ ਤੁਸੀਂ ਆਪ ਸੋਚੋ, is it possible if we are choosing in case 1 that the two gases they are different, and ਉਹਦੀ ਵੈਲਿਊ ਵੀ ਡੈਲਟਾ ਐਸ ਦੀ ਸੇਮ ਆ ਰਹੀ ਆ, ਐਂਡ ਕੇਸ 2 ਦੇ ਵਿੱਚ ਜਿਹਦੇ ਵਿੱਚ ਆਪਾਂ ਦੋਨੇ ਸੇਮ ਗੈਸਿਸ ਲਈਆਂ, ਐਵਰੀਥਿੰਗ ਇਜ਼ ਸੇਮ, ਸੋ ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਵੀ ਜਿਹੜੀ ਡੈਲਟਾ ਵੈਲਿਊ ਦੀ ਜਿਹੜੀ ਵੈਲਿਊ ਆ ਉਹ ਸੇਮ ਆ ਰਹੀ ਆ, that is having some positive value. So this conclusion is, so this expression of equation 9, it is unacceptable. Why this is unacceptable? Because ਜਦੋਂ ਆਪਾਂ ਕੋਈ ਵੀ ਦੋ ਗੈਸਿਸ ਜਿਨ੍ਹਾਂ ਦਾ ਸਭ ਕੁਝ ਸੇਮ ਹੈ, n1 is equal to n2, v1 is equal to, ਉਹਦੇ ਵਿੱਚ ਵੋਲੀਅਮ ਵੀ ਸੇਮ ਹੈ, ਹੁਣ ਜਦੋਂ ਆਪਾਂ ਉਹਨਾਂ ਨੂੰ ਮਿਕਸ ਕਰਕੇ ਫਿਰ ਆਪਾਂ ਉਹਨਾਂ ਦੇ ਵਿੱਚ ਇੱਕ ਪਾਰਟੀਸ਼ਨ ਕਰਾਂਗੇ, ਸੋ ਦੈਟ ਵੈਲਿਊ ਜਦੋਂ ਸਾਰਾ ਕੁਝ ਸੇਮ ਹੋਏ ਤੇ ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਜਿਹੜੀ ਉਹ ਪ੍ਰੋਸੈਸ ਆ, ਇਟ ਸ਼ੁੱਡ ਬੀ ਅ ਰਿਵਰਸੀਬਲ ਪ੍ਰੋਸੈਸ. बट इस केस दे विच की आ रहा साडे कोल, इस केस दे विच जिहड़ी साडी वैल्यू आ रही आ डेल्टा एस दी, सो दैट इज कमिंग आउट टू बी हैविंग सम पॉजिटिव वैल्यू. सो व्हाट डज इट मीन्स? इट सेज दिस प्रोसेस इज irreversible. So this is wrong and it is unacceptable. So Gibbs raised this point. So he said that the expression of this equation 9, it is unacceptable because according to this expression the delta S value, it is coming positive, which says that this is a irreversible process, or it means that the mixing of two samples of same gas with common initial temperature and with common initial particle density n, so it is an irreversible process. But it is not true because ਜਦੋਂ ਸਭ ਕੁਝ ਸੇਮ ਹੈਗਾ ਆ, ਸੋ ਅਗੇਨ ਅਸੀਂ ਉਹਨਾਂ ਨੂੰ ਮਿਕਸ ਕਰਕੇ ਜੇ ਪਾਰਟੀਸ਼ਨ ਆਪਾਂ ਦੁਬਾਰਾ ਕਰਾਂਗੇ and again we will measure the value of temperature and n for these two systems, so ਉਹਨਾਂ ਦਾ ਜਿਹੜਾ value ਆ it will remain same. So such a process, it should be a reversible process, and reversible process ਦੇ ਵਿੱਚ ਸਾਨੂੰ ਪਤਾ ਆ ਕਿ ਜਿਹੜੀ ਡੈਲਟਾ S ਦੀ ਵੈਲਿਊ ਆ ਉਹ 0 ਆਉਂਦੀ ਹੈ, but ਜਿਹੜੀ ਸਾਡੀ equation 9 ਆ, according to that the value of delta S, it is coming positive. So he said that there is some sort of paradox in this equation, so that ਉਸ point ਤੋਂ ਜਿਹੜਾ ਇਸ ਨੂੰ ਕਿਹਾ ਜਾਂਦਾ ਆ, so that is known as the Gibbs paradox. So Gibbs said that, so there is a paradox in the value of this entropy, and he has resolved further this Gibbs paradox by giving a new value of entropy or the modified value of entropy. So let's solve this paradox. ਹੁਣ entropy of mixing of two same gases with common temperature and common particle density, so it can be written as, so let us rewrite the equation number 6, so that is k n1 log of n1 plus n2 minus log of n1, because ਜਿਹੜੇ log ਦੇ denominator ਦੇ ਵਿੱਚ term ਆ, ਜਦੋਂ ਆਪਾਂ ਉਹਨਾਂ ਨੂੰ open ਕਰਦੇ ਆ, so that becomes minus log of n1 plus n2 log of n1 plus n2 minus of log n2. So this can be written as k, that is n1 log of n1 plus n2 minus n1 log of n1 plus n2 log of n1 plus n2 minus n2 log of n2. So this we can write as k n1 log of n1 plus n2 plus n2 log of n1 plus n2 minus n1 log n1 minus n2 log of n2. So let us add and subtract n1 plus n2 and n1 plus n2, add and subtract. So this equation becomes, so let us add these two equations because they are same. So this we can write as n1 plus n2 log of n1 plus n2 minus n1 log of n1 minus n2 log of n2. So this is the modified above equation. Now if we add and subtract n1 plus n2, so there will be no change in this expression. So this expression we can write as k n1 plus n2 log of n1 plus n2 minus n1 plus n2 minus n1 log of n1 minus n1 minus n2 log of n2 minus of n2. So when we move these positive values of n1 and n2 within the bracket, so we can write it as minus of minus n2. Now this equation from the Stirling's formula we can write as the value of delta S, that is k log of n1 plus n2 factorial minus log of n1 factorial minus log of n2 factorial. So what it says that in order to have the value of this delta S equal to 0, so we need to subtract the equation of k log of n from the whole entropy expression, or you can write as to obtain the correct result if the original expression of entropy were diminished or subtracted by term, that is k log of n factorial. So if we subtract the value of this S1 ਨੂੰ ਆਪਾਂ ਜੇ diminish ਕਰਨਾ ਹੋਏ, so it will be diminished by k log of n1 factorial. So similarly entropy of system S2, it will be subtracted by k log of n2 factorial, and the total value of S dash, it will be subtracted by k log of n1 plus n2 factorial, or you can say k log of n factorial. So therefore let us rewrite the expression of our entropy. So our entropy expression which we have derived, so that is nk log of v over h cube 4 pi me over 3n the power 3 by 2 plus 3 by 2 nk. So Gibbs said in order to get the correct value of this entropy, we will subtract the entropy expression with the term that is minus k of log n factorial. So our modified expression of entropy we can write as nk log of v over h cube 4 pi me over 3n the power 3 by 2 plus 3 by 2 and k. So k log of n factorial, using the Stirling's formula we can write it as n log of n minus n. So this expression becomes nk. So when we open this, so this will be equal to 3 by 2 and k plus nk. So this becomes 5 by 2 nk. So nk log of v over h cube 4 pi me over 3n the power 3 by 2 plus 5 by 2 nk minus nk log of n. So again, this is the logarithmic term, this is the logarithmic term. We can move this nk as common. So this expression we can write as nk log of v over h cube. So this log of n, because here it is an active sign, so this will come in the denominator. So I will write here with blue pen. So this log of n, that is with minus sign, it will come in the denominator. So this expression becomes 4 pi me over 3n the power 3 by 2 plus 5 by 2 nk. So again we can take these values outside. Nk log of v over n as outside plus nk log of, so if we put the value of this e as, so e is equal to 3 by 2 nkt. So this equation becomes nk log of 2 pi mkt over h square the power 3 by 2 plus 5 by 2 nk. So this is the modified expression of entropy. So this we can write as entropy is equal to nk log of v over n plus 3 by 2, which is in the power, it comes ahead. This we can write 3 by 2 nk log of 2 pi mkt over h square plus 5 by 3. So that 5 by 2 nk we have put inside the bracket by keeping 3 by 2 nk outside. So this is the new expression of entropy. So that is known as the Gibbs resolution of paradox. And this expression, it is also known as the Tetrode equation of entropy with modification values. So this is very important expression. So let us mark this as equation A, and this is very important. So generally they ask you in the examination what is Tetrode equation of entropy, or what is Gibbs resolution, or what is Gibbs paradox, and how Gibbs have resolved this paradox. Now if you use this value of entropy and try to solve it for the two systems, so which are identical system having two identical gases, so उस केस दे विच जिहड़ी वैल्यू आएगी, so the value of delta S, so that we can find out now n1 plus n2 log of v1 plus v2 over n1 plus n2 minus n1 log of v1 over n1 minus n2 log of v2 over n2. And if two gases are identical, so having m1 is equal to m2 is equal to m, and having same particle density n1 over v1, that is equal to n2 over v2, and the total it is n1 over n2 over v1 plus v2, and you can put these values in and find out the value of entropy of mixing with the modified expression, and it comes out to be k n1 plus n2 log of, so if I write v1 plus v2 as log of v2 over n2 minus n1 log of v2 over n2 minus n2 log of v2 over n2. So this you can say keeping the log of v2 over n2 as constant, so this becomes n1 plus n2 minus n1 minus n2, and these get cancelled. So the value of delta S, so for two identical gases, it is when the system 1 is equal to system 2, and the value of change in entropy, it is coming equal to 0. So what does it represents? So this represents that this is known as a reversible process, and which is equivalently justified if we perform it experimentally. So for two different gases, the value of this delta S, it again comes out to be a positive value, which shows that those processes in which the value of the two gases which are present in the system, they are not same or having different value, so in that case that process is known as irreversible process. So this expression of entropy, so it is justified for all the processes, and this relation is known as the Sackler tetrade relation of entropy. So once we find out the value of this relation, so from this relation we can find out the values of the modified expression of energy, and from that we can find out the various thermodynamic parameters. So let us try to find the modified expression of energy. Now if I multiply the above equation on both sides by 2 over 3nk, so this becomes 2s over 3nk, that is equal to 2 by 3. So nk get cancelled with nk, so this left with is v over h cube n 4 pi me over 3n the power 3 by 2. So 2 by 3, so 5 by 2 nk multiply by 2 by 3 nk, so this comes out to be as 5 by 3. So this 5 by 3 we can move to the left hand side, so this equation becomes 2s over 3nk minus 5 by 3, that is equal to 2 over 3 log of v over h cube and 4 pi me over 3n the power 3 by 2. So this we can write as, if I move these 2 by 3 to the powers of this whole expression, so this becomes log of v over nh cube the power 2 by 3 into 4 pi me over 3n, because 3 by 2 get cancelled with 2 by 3. So this equation becomes 2s over 3nk minus 5 by 3, that is equal to log of 4 pi me v2 by 3 over 3h square and the power 5 by 3. So taking logs to the left hand side, so the left hand side it becomes a exponential function of 2s over 3nk minus 5 by 3, so that is equal to 4 pi me v2 by 3 over 3h square and the power 5 by 3. So from that we can write the expression of energy as 3h square and 5 by 3 over 4 pi m v2 by 3 into exponential of 2s over 3nk minus 5 by 3. So this is the new modified expression of energy which is dependent upon S, V and N, and this is known as the modified expression for energy. So once you find out this energy, so that is generally the extensive parameters or the extensive physical quantity, and from this value of energy you can find the various other thermodynamic parameters like chemical potential, like pressure, you can find the value of temperature, Cp, Cv, so and so. So this we will do in our next lecture. So I think more than 80% of the first unit we have covered. So after the end of this article we will left only with one article, that is known as the Liberalist Theorem. So I hope you understand all these key points which are required in order to find these derivations. So what we have done in the previous derivation and in this derivation, so again we find out the value of entropy that is different for these two values, and from these entropy value we have find the parameters of energy, and from these energy expression we have to find the various thermodynamic parameters. So both these articles, that is the classical ideal gas expression of entropy and the Gibbs paradox and its resolution which gives a new value of entropy. So if you have any doubt you can ask your doubts in the comment section. So today I will also send you the soft copies of the material so which you have demanded. So till then, goodbye.